This is the 2011 F equals MA, and this is problem number 18. So we're given that we have some block on a ramp. So we have our ramp here. And our block has a mass m, and m is equal to 3 kilograms. Now we're told that it slides down one ramp, and then it goes up a second ramp. And the coefficient of kinetic friction, namely mu k, between the block and each ramp is 0.40. Now the block begins at a height, we'll just call this height, it's h1. And h1 is equal to 1.0 meters above the horizontal. And both ramps are at a 30-degree incline above the horizontal. And we're asked to find of what height above the horizontal does the block rise on the second ramp. So we know that our block's going to move down, and then it will start moving slightly upward. Now, if there was no friction, then h1, if no friction, then because energy must be conserved, we would have that mgh1 equals mgh. However, because there is friction, some energy must be lost. And the change in energy, the amount of energy that is lost must be equal to the work done by friction. So we know that h has to be less than h1 because now our block has less energy than from when it started because work was done by friction. So this is not valid because there is friction. So what is our change in energy? Well, we have our change in energy is our initial potential energy is mgh1. This is our E1, our initial potential energy, which is all of our energy. And we know that when it reaches the bottom, it's going to have all kinetic energy. But then it starts going up the ramp again, the second ramp this time, and when at the very top where it stops, it's going to have a kinetic energy of 0, and all it will have will be this potential energy. So we have that mgh is equal to E2. So our change in energy will just be E2 minus E1, which we know to be a negative number, and it's just mgh minus h1, so we have mgh minus h1. So now we want to find the work. We want to find the work done by friction. So first off, let's find the friction force. To do so, we can draw a free body diagram. So here is our ramp, here's 30 degrees, and we have our block of m here. Now the force of gravity is acting on our block, force of mg, and we can break it down into components, with the component downward being mg sine of theta, or 30 degrees, and we have a component that is perpendicular to the surface, and that is mg cosine of theta. Now we also have the normal force from the surface onto the block, and this is our normal force. And we also have our force of friction, Now we know that its acceleration is going to be equal to mg sine of theta minus the friction force. And here we just want to figure out what the friction force is. Now the friction force is equal to the coefficient of kinetic friction, since we know that it's moving, times the normal force. And the normal force must be equal to the perpendicular component of gravity that points into the surface. So namely mg cosine of theta, which is 30 degrees. So this is our friction force. Now we want to know what distance it has acted upon, because work is equal to the force times the distance. Force times the distance upon which it acted. So since our friction force, is acting parallel to both ramps, in this case when it's moving downward, the friction force acts upward. In this case, when our object is moving forward, the friction force acts downward. So we want to find the distance here and the distance here. Well, we can do that by geometry, because what we have is that this is H1, 30 degrees, and we want to find L1, and we also want to find some distance, L2, where this is H. This is also our H, and once again, this is 30 degrees. So we have that x is simply equal to L1 plus L2, or in other words, we have sine of 30 degrees is H1 over L1. So we find that L1 is just H1 over sine of 30 degrees. And similarly, we have that the sine of 30 degrees is equal to H over L2. So we find that L2 is just equal to H over sine of 30 degrees. And so we get that H1 plus H over sine of 30 degrees is equal to x. So now when we put these things together, we find that work is just equal to our friction force times x, and so we can plug it in.